Good day, students. On this clip, we're going to be going over an example on how to find the inverse of logarithmic functions and show that our answer is correct using tabular and graphical forms. Okay, so let's go ahead and write down the title, the instruction for the notes. So we are to find the inverse um, of the given function, and after that prove that your answer is correct using tabular and graphical methods. Okay? Alright, so let's go ahead and consider this one problem. The function we're going to be looking at is a basic logarithmic function, y equals log base 3 of x. Okay? So for this function, what we're going to do is we're going to find the inverse first, and then we're going to prove that our answer is correct using tabular and graphical methods. Alright? So first of all, to find the inverse, first thing we're going to do is we're going to switch the variables. Okay, we're going to switch the x's with the y. So this y becomes, we're going to have x equals log base 3 of y. Okay, what did I just do? I just switched the input and the output. Now I'm going to solve for y, and that will be my inverse. Alright, so since this is log base 3, base is 3, to get rid of the log, I'm going to exponentiate both sides using 3 as the base. So what I'm going to do is I'm going to put big 3 on both sides. We have a big 3 on the left and a big 3 on the right. Okay, I'm going to exponentiate both sides using 3 as a basis. So we're going to have a little x equals little log base 3 of y. Okay, so on the right side, these are inverses, so they cancel out. And then we're going to have, using the reflexive property of equality, y equals 3 to the x. Okay, so guess what? This y is the inverse of x. So y inverse equals 3 to the x. Alright, so is this answer correct? Well, let's see. What we're going to do is we're going to start out by using graphical methods to see if our answer is correct. So first thing we're going to do, let's make a table of the original function. So let's make a table for ourselves. This. Alright, so we're going to have x, and then in the center we're going to have y equals log base 3 of x. Alright, and then here will be the y, which will be the final output. Alright, so we're going to have just 3 arguments that we're going to put in. So we're going to start out with 1/3. Okay, so if I plug in 1/3 here, I'm going to have log base 3 of 1/3. Okay, now if I reciprocate this, this is going to become log base 3 of what? 3 to the negative 1. Now since the base and the argument of the logarithm match, they cancel out, and your final answer equals negative 1. So the output when the input is 1/3 is negative 1. Alright? Okay, so there goes the first row. We're going to have 3 rows. Alright, the second row is going to be 1. Okay? So log base 3, we're going to plug in 1 for the x of 1. Now can I express 1 as a power of 3? Absolutely. You can write this as log base 3 of 3 to the 0th power, because anything other than 0 raised to the 0th power is 1. So these are inverses, the log base 3 and the 3 cancel each other out, and the output is simply 0. So when x is 1, your output is 0. Okay? Alright. Alright, so we're going to move on to the last row, which is going to be, we're going to plug in 3. So if we plug in 3 into a function, what do we get out? So just x is 3, so we're going to compute log base 3 of 3. Okay? This is just basically log base 3 of 3 to the first power. Okay, if the argument of the logarithm doesn't have any power, the default power is 1. Okay? So the base and the argument are identical, so these cancel out, and your output is 1. Okay, so the output here is going to be 1. All right, this is a graph. This is a tabular representation of my original function. Now let's make a table of the inverse and see what happens. Okay, so I'm gonna make another table. We have x as the input, and then the output function is going to be y to the negative 1, the inverse, which is 3 to the x, and then we're going to put our final output results into the y column. All right, so I'm going to take the output from the original function and use them as my input here. Let's see what we get as the output. All right, so let's start out with number -1. So if I put in -1 into this function, I'm going to have 3 to the -1, which is equal to, we use the reciprocal property, is going to be 1 over 3. Okay, 1 over 3 to the 1 is just 1/3. So that's going to be our output, 1/3. Okay, next we're going to take the second output value from my original function and plug it into this function. Second output of value is 0. Okay, so we're going to plug in 0 into this function. So we're going to have 3 to the 0th power. Remember, anything other than 0 raised to the 0th power is simply 1. Okay, so my output here is going to be 1. All right, last but not the least, we're going to take the third output value from my original function and use it as an input on my inverse function. Okay, so the third one is 1, of course, and then let's put that in. So we're going to have 3 to the first power, which is just 3. Okay, so we have 3. All right, we have the two tables. Now what I'm going to do is I'm going to put these two tables nicely condensed next to each other, and then we're going to compare them. Okay, so let's condense the first original function with the input and output values. So we have x and y. In this case, y is log base 3 of x. And then when we plug in -1, we got 1/3 as an output. When we plugged in 0, we had, I'm sorry, I got it reversed. So for the original one, when we plugged in 1/3, we had -1. When we plugged in 1, we had 0. And then when we plugged in 3, we had 1. Okay? Now for the inverse table, let's put it condensed and see how they compare. So x and y in this case is 3 to the x. So if we plug in -1, we get 1/3. And when we plugged in 0, as you can see up here, we got 1. And then when we plugged in 1, we had 3 as the output. So let's take a look at these two tables and see if we can make any connection between them. What do you see happening in these two tables? If you look at these two tables, what you notice is that it's like they're the same tables, but they're switched around. You notice the x and y are switched here. If you switch the x and y here, you get this. If you switch the x and y here, you get this. If you switch the x and y here, you get that. So what does that mean? That means numerically in the tabular representation, these two functions are inverses. Okay? So let's write down our conclusion. We'll say that since x and y switch for the two functions, then they are inverses. Okay? That's one way of showing that they're inverses. Now what we're going to do next is we're doing the tabular representation. Now we're going to look at the graph. We're going to graph these two functions on the same coordinate system, and then we're going to see if they're in fact inverses. Okay? Alright, so let's go with our, that's our x-axis. And I mean, that's the y-axis, and that's our x-axis. Okay? Now, how will I calibrate so I can get the best graph out of this? Since there are thirds here, that tells me that I need to calibrate by thirds. Okay, both x and my y have thirds in them, so I'll calibrate by thirds. What does that mean? It means that every 3 tick marks will be a whole number. Okay, so for the x-axis, this is 1/3, 2/3, and that's 1. It's 1 right there. And then 1/3, 2/3, that's 2. And then 1/3, 2/3, that's 3. If this were 4, we'll go by 4s, okay? So just keep track of the fractions. All right, and then going the other direction, 1/3, 2/3, that's -1. 1/3, 2/3, it's -2. All right, we can stop there because the smallest negative x we have is -1. All right, going with the y's, y goes as low as -1 and as high as 3. So 1/3, 2/3, it's 1. For the y, 1/3, 2/3 is 2 for the y, and 1/3, 2/3, and that's 3 for the y. Okay? Alright, and then how low does the y go? The smallest y value in both tables combined is -1, so we just go 1/3, 2/3, -1. Alright, let's go ahead and graph. So we're going to start by graphing the logarithmic function. So for -1/3 on the x, for 1/3 on the x, we have -1 on the y. So this is 1/3 right here on the x. We go down to -1 on the y. There, right there. That goes your first point. And then for 1 on the x, we have 0 on the y. 1 on the x, 0 on the y. It's going to be this point right here. So that, let me change it color so you can see. So we have this point. And then we have another point right here. And then for 3 on the x, we have 1 on the y. So 3 on the x, 1 on the y. So there goes the graph of the logarithm. So let's draw it as best as we can. Let's do there, like that, and then it curves like that. Okay? So this is basically how logarithmic functions look like. It starts down here, and then it just curve out there like that. Alright? So this is a graph of y equals log base 3 of x. Now let's go ahead and graph the other one. To graph the other one, when x is -1, y is 1/3, so -1 and 1/3, that goes the first point. And then when x is 0, y is 1, that goes the second point. And then when x is 1, y is 3, that goes the third point. Okay? So try and draw the connected as best as you can. Like that. Like that. Curves out. And then this one curves out like this. Okay? Alright. Now, to finish this up, we're going to draw our line of reflection to indicate the inverse relationship. So from the center, you just go, we're going to draw the line y equals x. Y-intercept 0, slope 1. So rise 1, run 1. Like that, dot, dot. Right down the center for the line y equals x. Okay? Alright. For that, like that. So since this is not part of the graph, we're going to make the line dotted, okay? So make a dotted line for the line y equals x. Alright, now let's label it. This is the line y equals x. And this is the line y equals 3 to the x. Now what do you notice? You notice that this line is a mirror image of this line along the line y equals x. And what does that mean? That means this is the inverse of that from a graphical perspective. Okay, so the line is a reflection of another line on the line y equals x. That means that the two functions are inverses. Okay, so let's write down our conclusion from our graphical result. Since y equals log base 3 of x and y equals 3 to the x are a mirror image of each other, along the line y equals x, they are inverses of one another. They're inverses of one another. Okay? So what we have just done is we just showed that these two functions are inverses using a tabular right here and a graphical method. Okay? Tabular and graphical method. So there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel just by clicking up here for other cool videos such as this. You can share with your friends via Facebook and Twitter. More videos can be found on myprootsurf.com. Thanks again and have a wonderful day.